Chapter 3.7, Optimization Problems, Day 4. Quick review. What are the steps for optimization? Step 1. Label your variables. Assign symbols to all quantities. If possible, make a sketch. Step 2. Write a primary equation involving the variables to be optimized. This equation may involve more than one variable. To deal with the fact that your primary equation has more than one variable, you need to write a secondary equation that will get rid of all variables but one. Step 4, find your domain of your primary equation. And step 5, optimize using the first derivative test. We're going to do one more example of this. We're going to do an example that shows why it's so important to determine your domain. All right, so our problem today, we may do two if there's time. Our problem today asks 4 feet of wires to be used to form a square and a circle. How much of the wire should be used for the square and how much should be used for the circle to include the maximum total area? First off, this one's a lot easier to visualize if we draw it out. So we got a square and a circle, and the square's sides are x and x. The circle has a radius where our circumference equals 2 pi r. I'm writing that equation down because it's really important because we're asked to make a circle, and we make a circle by making a circumference. And what we want to optimize is area. So we want to get total area. Well, the area of the square is x squared, and the area of the circle is pi r squared. So that's our primary equation, and as you can see, it's got two variables, x and y, x and r. Sorry, old habit, x and y are usually variables in this case, so it's x and r. Now, our secondary equation involves the fact that we got 4 feet of wire. We've got 4 feet of wire to make a square and a circle, and we make the edges. Well, our 4 feet, if we use it for the squares, we got 4x plus 2 pi r for the circumference of the circle. And what I need to do here then is I need to pick a variable, either solve for x or solve for r, and substitute into my primary equation. What I'm going to do, because this r here has got that pi by it, I'm going to get rid of it, and I'm going to solve for r. So 2 pi r equals 4 minus 4x, and we'll divide r equals 4 minus 4x over 2 pi. You can simplify that if we want, multiples of 2 top and bottom. 2 minus 2x over pi. We'll substitute that in. Area equals x squared plus pi times 2 minus 2x over pi squared. All right, we'll clean this up a little bit. Area equals x squared plus pi over pi squared is 1 over pi. And then we need to square 2 minus 2x, that would be 4 minus 8x plus 4x squared. We will reorganize this, distribute, and rearrange it. Area equals x squared plus 4 over pi x squared minus 8 over pi x plus 4 over pi. So there is our primary equation, simplified down probably as far as you'd want to go with this. All right, let's get to a new screen. All right, and now we will differentiate it. We use the first derivative test. Remembering we want to take a look and define our domain and range. Should have done that a little bit quicker. If we take a look here, x is our variable. And what are the ranges for x? Well, if we look, we assigned x to the square. Well, the minimum x could be a 0 if we don't make a square at all. Or, if we use all of the wire for the square, each side would be 1 foot. So our values will be between 0 and 1. So we only want to check between 0 and 1. So we will take our derivative. A prime equals 2x plus 8 over pi x minus 8 over pi. We'll set that equal to 0. 2x plus 8 over pi x minus 8 over pi. We will add 8 over pi. At the same time, I'm going to factor the x. 2 plus 8 over pi. And we'll divide. And I've already done this ahead of time, so I'm going to punch this out in a calculator. It rounds out to about 0.56. 0.560, something like that. All right, so that's my critical number. And I'm going to build a number line, remembering my domain goes between 0 and 1. All right. Because of the pi nature of this, you're going to want to use a calculator to do your kind of your plug and chug. All right, so we're going to check between 0 and 0.56. I checked 0.2, and I got a value of negative 1.63. So that means in here it's negative. Between 0.56 and 1, I checked 0.6, and I got 0.18. So that means that's positive in there. So we can see that the x value that causes a relative min is at x equals 0.56. So when we go back and look at our question, make sure we answer it. The question says maximum area. Okay, what? I found a relative min. Well, it's asking for a relative max. So what do? Well, let's take a look. We have this critical number gives us a relative min. Well, here, this is a critical number, and that's a critical number. We're going to need to check those as well. All right, so what you're going to want to do is if you find that you find a relative min, but you want a relative max, that's why it's so important to have your domain. So you can say, okay, the critical number in between doesn't give me the maximum. Let me check the endpoints. So what you want to do is in your calculator, enter your equation. And we're going to use the extreme value theorem. It's a continuous function. There needs to be a max and a min somewhere. We found the min. Now we need to find a max. So I'm going to type in my area function. X squared plus pi times 2 minus 2x over pi squared. All right, I'm going to look at the table here. And if I plug in 0, I get an area of 1.27. If I plug in 1, I get an area of 1. So, if I use all of the wire for the circle, I get a total area of 1.27. If I use all the wire for the square, I get an area of 1. And if I use 0.59 for the square, I get an area of 0.56. So, how much should be used for a circle? All of it. All the wire should be used for a circle, and you'll get a maximum total area of 1.273 square feet. All right. So, in conclusion, optimization. You're trying to find when something's maximum or minimum. That's what optimize means. What's the best or the least amount you can have in a situation. First step, you want to define your variables. Everything in a situation must have an x, a y, an r. Excuse me. Make a sketch if possible. Once your variables are defined, let's write an equation. A primary equation. What do I want to optimize? What do I want the most of? What do I want the least of? And remember, don't worry if there's more than one variable in a situation. Once you've done that, then worry about the fact that there's more than one variable in the situation. And you'll do that by writing a secondary equation to get rid of those other variables. Once you got your variables eliminated, let's look at domain. What values make sense in the problem? And then we will solve the problem, optimize it using the first derivative test.